I will focus today on my first objective, and I will present you mostly the data I have for now, and a little bit of exploratory analysis, and then what are the next steps and your questions. So this is my thesis topic, main topic, so I will try to analyze the dengue in a spatio-temporal way, and I will focus on different scale, first at national scale, or at least the affected area, and then the city scale with Tartagal and Córdoba. Yes, and of course I will focus on Argentina. So a little bit of context. Dengue re-emergence appeared in 1997 here in Argentina, but the first main outbreak was in 2009. And the most important outbreak was this year, a really big outbreak. I'm sorry about the Aires adjective, it's not properly written. I forgot to change it.
Somos muchos biólogos acá, es un problema.
So imagine that it's italic and with
uppercase.
Yes. So, as you know, dengue is a disease, a vector disease transmitted by the bitten of these little things. And here in Argentina, the affected area is northwest, and this is the case for 2020, just to have an idea. Okay, so you can look at the year cumulative cases with the main outbreaks. So you can see that this year was the worst one. So my thesis will be separated in three main objectives. Or no, it's like that. I will go back to the first one later, but the second one will be a comparison of spatio-temporal distribution of mosquito and cases. I will put both data together, and I will compare the distribution dynamics between the two cities of Tartagal and Córdoba. I will try to do that at least. And then the third part, I would like to include a more qualitative approach with the risk perception, which so far I know it's not already done for Argentina. So, first objective for now, it's the spatio-temporal analysis of the epidemics for the whole periods, so 2009 to this year. For now, I don't have the data for this year, but I hope I will get it. And of course, I have the data for before 2009, but it's not really relevant, but there is only few cases. So I will start with a global analysis, including climatic and geographic variable as control factor, but I will focus on demographic and socioeconomic factors, and also mobility and transport, depending on the data I can get. I will focus on cases and not the mosquitoes data, and on human aspects, or more precisely on where the people are, because if there is cases, they should be human. Yeah, so the evolution of the spatial distribution, and the method I considered for now is to start with a GLMM model, start simply, and then go for a random forest and maybe a Bayesian model with IGLA, for example. So the data I will use, it's all of that. And of course, we can start with the dengue cases by department. So this is the cases for the whole period. You can see that when there is an outbreak, there is really more cases than the other years. So there is cases for all years, but the dots are so so little that you can see it with the same legend. But this is interesting, but because we can see that there is really different pattern through the years. And this is the distribution of the case, and I will try to handle it because, as you see, there is 233 not really department, but times where a department gets only one case for the whole years, and there is for the whole period, and there is only one department who gets one time 15,000. So there is a lot of outliers, and it's difficult to handle this kind of distribution in the variables. So I will try to maybe get rid of some data or just take care of the peak years in I don't know how to do that, but like that you see that it's not really easy and it's not a Gaussian distribution we could expect. So this is the main outbreaks, and also this 233 one. It's mostly in 2020 where there is, you maybe see it, there is dots in the south. But what I think is that it's imported case from people who just go back home, maybe for the lockdown or I don't know. And it's totally not case from, there is no dengue there, of course. So I will remove it and focus only on the affected area to remove a part of this one data. So then for the human part, I will try to handle the sensor data. The problem with the data is that there is only 2 years, 2022. Here's 2 examples of data I can get from that. It's the household with water pipes in the home, so it's hogares con cañera en la vivienda.
Con agua en la vivienda.
And so I will try to interpolate it. I did an interpolation for the whole period in using a linear interpolation. But as you can imagine, it's not perfect and it's not really the reality because the variable doesn't evolve in a linear way, I guess. I'm not sure, but I will try to find the best interpolation. So this is the public water supply. And then I will try to get some good mobility and transport data, and there is some really nice data I could use. First, the inflow and outflow people on the territory. The problem with that data is that I get inflow and outflow in one number, but I will be more interested in inflow because as I'm studying dengue in Argentina, I'm not outside. But still, it's a good way to see where dengue could enter. And if I manage to, I don't know, separate it or maybe just take the half number, I don't know, or to have an approximation. Then there is this really nice data set with landing and takes off, where I can see, I just keep only the landing, and then I know where they land, from where they come, so it's really interesting, and the number of people. And I also could, I could just get the domestic to see how the people are moving inside the country, or I can get only the international to see where they come from, and maybe they come from Brazil, where there is a lot of dengue, I don't know. So it's interesting. And then there is this other really interesting database, but it's only from 2019 to this year. So it could be really interesting to have for the whole period because it's matrix, so it's really precise and detailed data. Here you have the, so if it's for cargo transport, and you have, for example, the regional food, you have the meat, and and the meats there. So different types of goods. Then, as I said before, I will focus on the population, where they are, and how it can influence the distribution of the case through space and time. And for that, I need to know where people are. So I will use WorldPop with population counts, but not only that, because if there is people, there is urbanization. So I will try to get a whole picture of urbanization and people, combining different data sets. So WorldPop first. There is differences, but at this scale we can't see really well. And then the nighttime lights, which is like really interesting data. Here we can see light differences, but if we zoom on Córdoba, for example, I just choose a random city, we can see like difference between in 10 years only. And then, of course, to study the urban area, I will use...
Sorry, voy a interrumpir un ratito porque las filminas no se están pasando, entonces nosotros nos quedamos con la primera de presentación. Lo escribimos en el chat y en el grupo, pero no nos están escuchando, por eso tuve que interrumpir.
¿Y qué habrá pasado ahora? ¿Ahí ven mi pantalla?
Sí, o sea, no la vemos como en presentación completa. ¿Te das cuenta?
No, porque ahí puse escape. ¿Pero ves la diapo de data?
Sí, pero se cambió recién, digamos.
Ok. Y a ver, voy a poner presentación de nuevo, a ver si ustedes ven. ¿Ahí qué diapo ven, Berito?
La misma, pero no la vemos en formato presentación, digamos.
Ah, qué raro. Okay. Pero está compartida toda la pantalla. Voy a dejar de compartir y probar de nuevo.
Dale.
Hola. Ok, vamos de nuevo. Presentar. Entire screen. Ok. Estoy viendo lo mismo en las dos, o sea que no importa cuál. Es que estaban escribiendo en el chat, pero nosotros no estamos viendo el chat. Bueno, vamos de nuevo. A ver si ahí funciona.
Sí, en el grupo escribieron menos.
Sí, ahí sí.
Ok, y si yo paso...
Excelente, perfecto.
Ok.
Ya estamos bien.
Listo. Uy, se perdieron como un montón, perdón.
Te vuelvo un poquitito para atrás, por lo menos para mostrarlo en los datos.
I can just go back a bit earlier. It's better. So what I was saying is that I will use the night lights to get insight about the urban area. And if we zoom on Córdoba, you can see like there is a huge differences between the in 10 years. And then, of course, I will use the long cover from ESA or MODIS, but no, it's ESA data. And here again, you can't see really the difference, but again, if we zoom in a random city like Córdoba, you can see that there is a huge difference between 2009 and 2020, so in 11 years. And this is the difference. So it's quite a lot. And if we get the percentage of change for the whole country, it's almost 30% of urbanization in 10 years, a bit more. And for Córdoba, it's 23, a bit more. So it's quite huge, and I guess I can really use this to see how the population are growing, but also I guess there is differences in through the departments, and maybe if I can get these differences, I can also link that with the cases and see if it's match. So, as an exploratory analysis, I started a GLMM model where you can see the formula. So, my dependent variable is the number of peas. And then I use two variables for now. The one I presented to you earlier, so with water or in the house. And I set the year and the department as random effects, because it was working better if I get the two than if I just add the year. And this is the results, which is not really looking nice, because I don't use the proper interpolation, probably because there is collinearity between the variables, and probably because of the distribution of my cases.
Yes,
So all of that make it wrong, but still we have good p-values. Good, I would say. Not really good, but
a clear example that you cannot keep the p-values only for interpretation and inferences.
Mostrarles dónde está porque dice que es malo. Bueno, arriba está.
Ahí ella comparó
Claro.
usando con y sin factor aleatorio del departamento. Este da un poquito mejor, pero la hice arriba de todo, da 87.000 y pico.
Claro.
Si bien tiene sentido solo comparándolo, igual como que la deviancia está alta.
Sí.
Y fue 400.000 sin departamento.
Claro.
Mejor.
Claro.
And then what are my next steps? Further exploratory analysis, so to have a better GLLM model, but also to still exploring the data. For example, for the dengue cases, I need to handle this distribution and to see what can I do to better use it. Maybe use the incidence. And also, of course, I need to develop a methodology to interpolate all the data, because there is some data that I have for the whole periods, but not all of them, and especially the one for the socioeconomic parts, which I'm really interested in, so I need to work on that to have the better pattern and make it more real. And after that, I will try to have a good model with random forests or